So, hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra, and in this class I am going to discuss about some important questions from the manufacturing subject with respect to your GATE examination, and specifically we will be discussing questions that can come in the GATE exam 2021, because we will be discussing questions from the recent months, and also we will be discussing about the questions which are from the conventional GATE papers, which was from all the way back 20-30 years, but we are going to learn a lot from them. And therefore this class, I think it will be very worth your time that you are spending here, and you will find that this class is helpful and beneficial if you stick with me for 2 hours or so for the session. And we will be discussing, along with the important questions, the tips and tricks to do that question properly, the errors that you can make, so you should be aware of that errors, and therefore we should be discussing about potential errors also in this class for you to be just aware of. And we will also see and follow the right approach of a question, of solving a question, and also that approach that we are going to follow will be such that we do a question or solve a question in the fastest possible time. So this is all things that we will be studying, and accumulating all this thing, you will find that this class, this 2 hours or so class, is totally worth the time spending. So just focus on the things that I'm going to teach you for, and for 2 hours or so. So let's start by talking a bit about me. So I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi, and I have got a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are photo editing, video editing, cricket, football, and I like all sorts of games. So I will be taking this class entirely in English, so that a whole lot of students can watch me, because this language is familiar to a lot of students, a vast variety of students, and also because we are studying the subject mechanical in English only. We are just studying the technical terms in English only, so it is better that we just stick with that. And therefore you will find this class entirely in English, but it will be a very simple one, so you can, I think, easily follow me. And also, since I have both prepared and taught for GATE examination, so I have accumulated over the years a lot of tips and tricks, a lot of things that you have to just take care of, you have to just know, so that you are well prepared. So just be rest assured that the time spent here during my classes will be worth your time. Okay, so Unacademy's learning app is free for you to download. So just download this app, and since this is free for download app, so it is there for you to just check out and just see if you can resonate with the app. This app has got all things covered. So name one thing that you think is important or necessary for your GATE preparation, and you will find that this app has it. And in one line you can say this app is a complete package. And as you can see in the screen, everything is covered in this app, so that you are preparing online in the best possible way, and free of cost. So just download this, check it out. There is no harm in checking a free to download app, and just see for yourself what you can just take advantage from this app. Unacademy's subscription plans are there for you to choose from, and the benefits offered by those subscriptions are listed in the screen or shown in the screen right now. So we will go through the benefits, and before that, what Unacademy subscription plan basically is. It is basically a purchase that you have to make. It is basically a fee that you have to give to get all the Unacademy's content without any limits. Okay, so for example, when you are subscribing to Unacademy for say 1 month, then for that 1 month duration you will be just provided access to daily live classes where you can ask your doubts, answer polls, and you can do this all while the class is going on. So the live quizzes and test series are also there for you to just solve and just take benefit from and evaluate your performance, and also detailed analysis of test series will be provided to you. And all the courses are structured in such a way that you are preparing in a progressive manner, and also you are preparing in a manner which creates your rhythm. So Unacademy's educator are making sure that the way you are being taught is a way which is the most efficient and effective. Therefore, the structured courses are making sure this thing. And unlimited access of content will be provided. This means that if you are subscribing today, then not only you will be getting content from today onwards, you will be getting content before that day. The content such as classes which was held a month ago or so, a week ago or so, you will be provided access to that. So you will have a lot of content to just choose and study from. You just have to select a content, select a course, and start your preparation. And these are some quality features that Unacademy is providing, and all the things here listed are far better than what you just see in the YouTube classes, because YouTube is not designed specifically for education. It is designed for a general video streaming platform. But Unacademy is specially designed keeping in mind what a student needs, what a teacher needs, and therefore you can have a better focus and better time learning in Unacademy's website than in YouTube or sites like that. And again, that I have mentioned that top educators are there for you to just study from, and these educators are obviously very well qualified in their respective field, and they will not only provide you the best possible path to follow to score good marks, but they will also give you tips and tricks and share their experiences. So all this you can just take advantage of by just coming to an Unacademy class and just being attentive. And there are multiple educators for a single subject, so there is also a nice option for you to choose from. And the subscription prices are shown here, and these prices, as you can see, are available for a large number of months option. For example, 1 month option is there, 3 months option is there, 6, 12, 18 and 24 months option are also there for you to just select and just subscribe. And the best plan here that I am going to just mention right here, if you can see the amount of discount offered in each of this plan, you will find the best plan for you to just select is either 12, 18 or 24 months plan, because they are offering the most percentage discount. And if you want to just get more discount, if you want to just get more savings, then this 10% off code ABHIMI is there for you to just use and just save more. And again, if you enter this 12-month, 18 months and 24 months subscription plan, this code, then you will find that you are getting more discount, because the 10% will amount to a lot more for this last three plans. And this subscription that I have been discussing about, I have just shown you, is for plus type, which is basically classroom type teachings, where an educator will teach a number of students, and you along with the other students can discuss with the educators in a class, in an online class. So that is what plus subscription is for. And you can also have a no cost EMI option for your payment for 6 months and above subscription plans. So everything that is needed for your just preparation, so that you can just prepare in a way in which you can give a reasonable price and then just assess all this content is there. You just need to select a plan and start your preparation. And I will also show you the discounted prices, the ultimate price ultimate low price that you can give. You can also say the final discounted prices after you have entered this special code that you are seeing right here in the screen, ABHIMI. So this is the new discounted prices, or the discounted prices, which is the final lowest price that you can just give Unacademy and get a subscription. And this price is only possible if you enter the code that is shown right on your screen. And again, just select one of the plans that you can just afford and which you need, and just start your preparation. And another subscription type is iconic. So this is for those who need more assistance, who need personal coaching, personal study materials, things like that. And 10% off code ABHIMI still applies here, and the new discounted prices if you use this code will be this. And again, these are some reasonable prices. You can just give no cost EMI option payment and get the subscription via that. And again, the prices that you are shown here, that you are just seeing here, and that you will pay to get this subscription will be totally worth spent because of the amount of content, the richness of content, and basically just the things that you are getting are totally worth it, are totally reasonable for the Unacademy's team to ask the price. And the plus and academic subscription, finally you can see the subscription benefits here, and this is the last slide for our discussion of Unacademy's subscription plan. And again, I am just stressing out or just pointing this out that this is the code that you can just use to get 10% off. If you are not using this code, then you are basically not getting the 10% extra discount, which amounts to thousands of rupees for some plans. So that will obviously a thing that you would like to do savings. And therefore this code, you should just remember this, and just try it out. Try Unacademy for 1 month or so, then you can just commit to a more months plan. But just try it out and see that if you are trying it out, then give it your full focus. Don't just think that you have to just subscribe to Unacademy and just be just rest. You have to prepare using the content, and therefore just subscribe to Unacademy, use the code, get a subscription package, and just start giving test series and things like that, and just evaluate your performance, analyze it, and just prepare in such a manner that you are satisfied at the end of your preparation. And when you give the GATE examination, you are just confident that you have given your best, and therefore just you can just concentrate on the paper that day. And that's it for the Unacademy subscription. Now let's start our discussion of the important questions. Like we were doing for the previous 9 classes, we were discussing important question, and we will continue it right now, right here. So our first question, and also as you can see in the screen, I will be showing you the code throughout this class for you to just check it out. If you in any case you are just wanting the code to be just use and get a subscription, you can do that, because I will be just showing this again and again for you to just simply look into it and assess it when you require. So let's start the class. So the first question here is, in sheet metal processing, the main function of punching process is. So in sheet metal processing, what is the main uh, function of punching process? The question is asking us, is it to create a blank, it is to create a hole, or produce both hole and blank, or just to make a cut at an edge of sheet? So the options are here, and I expect you to just answer this question. So if you're watching the recorded or archive session, you can just take your time. This question can be done in 20 seconds or so. And after I have just gone through all the options, you should just select an option while I was just reading it. So let me show you one thing that will help you understand this question more. This is one of the easier question from the basics. So let me show you the thing. So this question is quite easy and you should have answered this question, and let me answer this question right now and then we will discuss more about it. So the main function of punching process is to create hole. So B will be the correct option. Our main focus is to create hole in punching. So punching is the thing that was asked. And for blanking, remember, blanking process is just what this blanking is made from. So blanking simply creates blank, which is basically the disk that are cut out after you have just made the sheet metal operation. And this is right here is the image that you can see to just simply understand what punching and or piercing and blanking are. So they both first of all are sheet metal operations. So you can see the workpiece and scrap idea for both blanking and piercing are opposite. First we will discuss about blanking. In blanking, our main focus is to create this disk or blanks. So this is the disk or blank. Our main focus is to create them. And for the next piercing, our main focus is to create this holes. So the workpiece will be this blue object, okay, and scraps will be the pieces that are cut. And here the pieces that are cut, our main workpiece, and the blue part is our scrap. So the pieces that are cut will be there in circular shapes. So this circular shapes discs, you can say them disc, blank, things like that. So this will be your, so this right here will be your main workpiece. And for blanking, remember this always, you can remember that whenever disk or blanks are there as our final objects to be made, then always remember the process will be blanking process. So you can remember it like that. If disk is there in the question as final object, if blank is there in the question as final object, then blanking is the one that we are doing, is the one process of sheet metal operation. And piercing simply means that you are removing that circular part from your workpiece to get this final object as your finished product or as your desired product. You can remember this piercing thing by that in your ears, in ears of female, what we do generally for female, that we do a piercing. So there we just remove the part to just put some earrings. So there you can see the what piercing represents here is also representing there, because there our main workpiece or main desired part is not the thing that is removed, it is thing that is left. So that's, you can remember piercing by that, because that process is also known as piercing. You can just remember ear piercing and things like that. Nose piercing is also one. So I hope you have understood the question, and this question was quite easy, but I thought you should just revise the thing here as our first question. And the second question is just follow up to that question. I just wanted you to just first of all understand the question that I taught before this question. Then after that question, this question naturally comes, because here is an advanced version of the thing that was asked in our previous question. So with reference to clearance between punch and die, so there will be clearance between punch and die for just clean and easy cutting of the discs or blanks or the removal of that part to create the holes. So clearance is between the punch and die in sheet metal processing. Which of the following is true? And I am now reading the options. Again, as I am reading the options, when I have just completed reading the options, I expect you to just give the answer by that time. If you are watching the recorded session, you can just also follow this thing. So the first option is punch size controls the hole size and die size controls the blank size. So is punch size controlling the hole size? Is punch size is in punching we require our workpiece as with holes, or in die we or in blanking where die is controlling blank size? Is it true? Punch size control blank size and die size controls hole size. Punch size controls both hole and blank size, and die size controls both hole size and blank size. So which of the following options that I have gone through is correct? And basically by controlling it is meaning that the punch size, is it equal to hole size in a punching process, and is the die size equal to the blank size in the blanking process? Is it like this or the other way around, or option C or D? So the correct answer to this question will be, as I have discussed and as you can see in this figure, the correct answer can be the answer option A, which is stating that so option A is stating that punch size is controlling the hole size and die size is controlling the blank size. So remember that punch is controlling hole size because in punching our workpiece is with holes. The cut part, the removed part are the scraps, and for blanking die size is controlling the blanks size because the rest of the part which is left after the blanks and discs are removed are the scrap. So again, see this figure for the last time here in this class and just absorb the details here, and I think now you are 100%, you should be having 100% clear of what punching and blanking are, and in punching or blanking punch size is controlling what and die size is controlling what in what processes. So now let's move forward and continue our discussion by doing this conventional question, which is, as I have discussed before in our class, this question is from the official GATE conventional paper and we are going to discuss that only right here. So in this question, since this question is from the official GATE paper, but 30 or 25 years ago GATE questions were asked in conventional forms also, so it is better for us to just revisit them and learn from them, because when I just see the questions, when I will just make you do the question, you will also find out that this type of question might get asked in your GATE examination, or some part of this question might get asked. So it is better for you to properly understand and do this type of question, which is, although not new, they are new because they had not been asked for your objective types in that frequency. So in this question we have a very simple one, so let's discuss that. So a part can be machined in 30 minutes on an engine lathe, whereas it can be machined in 6 minutes on a turret lathe. So we have an engine lathe and a turret lathe, and the parts can be machined faster in a turret lathe, which is 6 minutes, and 30 minutes is being taken to machine that part on an engine lathe. However, it would cost additionally 500 to tool up the turret lathe for operation. So additional 500 is required to just use that turret lathe. If hourly rate including labor and overhead is 80 for the engine lathe and 160 for the turret lathe. So since turret lathe is taking less time to machine, but it is having first of all an additional 500 you have to pay to just use that, to just run that, and then hourly rate is also greater, 160. So it is saying that if you just look into both of these lathes, the minimum number of parts required to make the turret lathe more economical to use for the operation, because in the long run you will find the turret lathe is economical. From the question itself you can just look into like that, the turret lathe is economical only when you are using it for uh, a minimum number of parts, which is obviously having some value, which is not just for say 2 or 3 parts, because for that your turret lathe will be more just expensive, because first of all it is taking additional 500 rupees to just use, so that we have to justify to create a large number of parts. So it is saying how much part minimum is required to make the turret lathe more economical. So let us do this question. Again, this question is from the GATE conventional official paper, so be rest assured that this question is a quality question, because this is again from the official papers. So let's do that by in this blank screen. So just remove this, and if you know the solution to the question, I hope you just provide me the answer in the comment section. So let's write for engine lathe here. Cost for engine lathe. So if both the costs are equal, that we have to just pay to make use of engine lathe and turret lathe, then we will find this minimum number over which or after which turret lathe can be more economical to use. So 30 minutes, a part can be machined for 30 minutes. So let us just write that 30 minutes per part, and 6 minutes is for turret lathe, and it would cost additional 500, it is written, and hourly rate is 80 for engine lathe and 160 for turret lathe. So that will be 80 rupees per hour. So per hour will be 60 minutes, and we will have here 6 minutes 500, 160 hourly rate. 6 minute per part, ₹160 per minute, and we have this additional cost of 500 which is just required to use this. So this is just required to make this run, this turret lathe, which is obviously we are going to find it as more economical after certain number of quantities, and that quantity we have to just find. So Q is the number of parts produced or we are producing. So you have to find this number of parts, after which we will get this turret lathe as more economical one. So simply we have to solve this and we have to find the answer, and I hope you do this right here and give me the answer if you are watching this live. This now becomes quite easy one to just do. So I will give you 30 seconds to just solve the question and provide me the answer in the comment section. And in the meanwhile, I am also doing that. So here I have not written 60 because again this was given rupees 160 per hour. So just remember that you have to properly write the units. So what we are getting right here, I hope the time was sufficient to provide the answer, was 24 Q is equal to 500. So from here the Q, the minimum number of parts after which turret lathe will become economical, is obtained. So it will be 500, simply 500 divided by 24. So it is coming out as 20.833. Now one more important thing that you have to just take account into here is Q. We have been asked minimum number of parts, minimum number of so the OBS got disconnected due to just electricity just going out in my region. And as I have told you in my previous class that I am just fixing this issue by making my inverter connection to one of the sources of just electricity here, one of the boards here. And to do that it will take some time, and because of some complexities involved here. But let's continue our today's class. That we were discussing about this question, and in this question it was basically what was asked is that engine lathe and turret lathe was given, and we have to find the minimum number of parts to make the turret lathe more economical for use. And therefore we have followed this approach, that is cost for engine lathe, or cost that we are providing when we are using engine lathe, and that cost we are also, that the cost we are giving for turret lathe, we are making this costs equal, so that after this cost we will find, below this cost we will find engine lathe to be more economical, and above it we will find turret lathe to be more economical. And the reason of turret lathe becoming more economical after a certain number of parts is that there is additional 500 rupees we have to pay to just use that turret lathe, and therefore we have to justify that 500 by making a large number of parts produced. And also what we were discussing here is that Q is the minimum number of parts that we have found out using the equation right here in the screen. And after finding this part, this value of Q, we found that it is 20.83. But it is just asked here that what is the minimum number of parts. So the minimum number will not be 20, minimum number of parts should be whole number. So first of all you have to just understand this thing, that it should be 21. It shouldn't be 20 because 20.83 is produced, and we have to just create this in whole number, so it will come out as 21. So if you create 20 parts also, you will find your engine lathe to be more economical and turret lathe to be less economical. So at least 21 parts needs to be produced so that your turret lathe becomes more economical after that, or during 21 parts creation also, just more than 20.83. But since this parts are whole number, there is nothing such as 0.83 part, it is always 1 or nil. So therefore we have just made that 21. So I hope this answer is clear to you, this question is clear to you. So let me just write its answer here. Now let's do the next question. So the next question is from orthogonal cutting operation, and in this question it is given that depth of cut is 2 millimeters, width of cut is 15 millimeters, cutting speed is 0.5 meter per second, rake angle is 0 degrees, the cutting force and the thrust force respectively are 900 and 600 newtons, and the shear angle is equal to 30 degrees. So these are the data that are provided here, and we are being asked in the first part of the question that what is the average coefficient of friction between chip and tool. So average coefficient of friction between chip and tool is asked to us. So we have to calculate mu, and after calculating mu we can just write its value or select its value from the given options. And to calculate mu we have to know beta, because mu, that is the coefficient of friction between chip and tool, is equal to tan beta. So we have to know beta, that friction angle. And to know beta we know a formula that we have discussed in some of our previous classes, and as recently as in our just the previous class we have discussed that formula, and I have just pointed out to you that you have to remember that particular formula. You don't have to just rely on the merchant circle and just think that you will derive that formula during your GATE examination, because it will take first of all a lot of time for you to do that, and that is just not that beneficial and not that good for your GATE exam, that you are just calculating this deriving this formula on the while the exam is going on. So you should just know this, and that formula that I am discussing right here is, so what we are going to do first of all is we are simply going to just add a blank slide here. So let me do that. So let's do the question here. So the first part of question that we are doing right here is asking us the coefficient of friction, which is nothing but tangent of beta, where beta is your frictional angle. So what will be the value of this mu? So to know the value of mu we should know first of all the value of beta. So let's do that. Let's select a different color pen here first of all. So this formula you should know that I was talking about. This is one of the most important formulas, and we have just we saw and we are seeing also that this formula's question is coming how much more frequently, this and that phi formula, that is the shear angle formula. So let me first of all erase this also. So it is the ratio of Ft and Fc, where Ft is your thrust force, Fc is your cutting force, and Ft is given as, in the question, thrust force is given as 600 and cutting force as 900. So the answer to this question will be obtained when we find beta first. So beta minus alpha is coming out as tan inverse of Ft divided by Fc. So 600 divided by 900, its tan inverse will be coming out as 33.69, and we will leave it like that only. We will not make it 0.70. No need to just do round off here. Because you have to use calculator, so there is no need to simplify your calculations by little bits. So beta minus alpha is this much, and let's see if rake angle is given or not. So rake angle is given as 0 degree. So here you can see that rake angle is given as 0 degrees. So we will use that and we will find the beta is equal to 33.69 only. So mu will become 10 of 33.69 degrees. So this will be equal to 0.66. So 0.66 is the value of 0.66 right here is the value of coefficient of friction, and we have been provided with this options. So is 1 by 3 equal to 0.66? No. 3 by 5? No, it is 0.6. And 2 by 3, yes, it is equal to 0.66. So just do 2 by 3, 0.66. So the correct answer is C, 2 by 3, which will be the value of coefficient of friction coming less than 1. That will be the according to the logic also. So that is the right answer. Now cutting power in watts is asked. So what will be the cutting power in watts? And we will do that here only. So cutting power will simply be Fc into V, where Fc is your cutting force and V, small v, is your cutting speed. So cutting speed is given in the question 0.5, cutting force is given in the question 900. So 0.5 into 900 will simply come out as 450, and this will be in watts. So 450 watts is the correct answer, and again very easy. And length of shear plane is asked. So this is a new thing due to which I am making you do this question, length of shear plane. So let's do this question. It will be equal to so what we have been provided with here is we have been provided with width of cut and cutting speed, rake angle, and what we have to find here is length of shear plane. So length of chip. So what we can do here is we can just find out, first of all, since this is orthogonal cutting, therefore depth of cut will be equal to width, so that we have been provided with, and this width we have to just use the divide it by the proper factor to get the length of cut. So let's do that. We have to find the phi first. So for length of shear plane we have to find phi, that is the shear plane angle, and phi will be obtained using this formula. So again you can see this formula is coming, and cos is alpha is 0, so this will become simply as not 0, it will become 1, alpha will be 0, and this will become 0, so it will become r. So from here we will just say phi is coming out as tan inverse r, and r right here is we have been given depth of cut, width of cut, and these are the things that we have been provided with, and from here we have to find out about phi. So let's see if we can do that. So width of cut is b, depth of cut is 2, and orthogonal cutting operation is there for us to just consider. So let's see this. So shear angle is given. So I was just thinking, if r is not to be found, then how we can calculate shear angle? But it turns out it is already given in the question. So that is one thing that I have just made the error of. So apologies for that. So phi is already given. Shear angle is already given as 30 degrees. So length of shear plane will simply become 2 mm, which is given in the question, and we have to divide it by sine phi, which is 30 degrees. So this will become as 4 mm. So the answer to this question, length of shear plane 4 mm, and I hope you have just understood this question properly. See, depth of cut is given as 2 mm, and the length of shear plane is asked. So we have divided that value by sine phi, because as you can remember, the shear plane area is given as this. So we are dividing this sine phi, which you can see in the figure will be something like this. So if you can see the figure, of your workpiece and of your tool, so this right here will be your shear plane, and this right here will be your shear plane angle. So let me draw it by using a different color. So this is your shear plane, and this is your shear plane angle, shear angle. So let's just zoom this triangle, right angle triangle here. So this is phi, this is your depth of cut or T, and this is your, so this is your D, not depth of, simply, and this is your, this value, this length we have to take, we have to consider to calculate shear plane area. So shear plane area will be like this will be shear plane area in 3D. So for shear plane area we have to multiply b, which is the width, with this t sine alpha. So in this right angle triangle you will get sine phi as, not alpha, sine phi as t by this length. Let's take this length as ts. So t divided by ts will be sine phi. From here we can say ts will be t by sine phi, which will be greater since this is hypotenuse in this right angle triangle, and we will multiply this will with width, then we will get the shear plane area. So length of shear plane, which because this is width, this will be length simply by that means. So length of shear plane will simply become equal to t by sine phi, and phi is given in the question, and we are also using this bt by sine phi to calculate shear strength. So from there only we are getting this shear plane area, and I hope this figure is also clear to you and this answer is also clear to you. And here t is the depth of cut which is given in the question, and you can see how this is depth of cut, because this much of depth is there, this much of deep the tool is just going to cut the workpiece. So that's it for this question, and the answers are here for you to just look into in the screen. So I've adjusted the settings here so that we can have a nice smooth session now since the electricity came back. So let's discuss from where we stopped. So we discussed this question entirely, and now let us see what we can see in this question. So here depth of cut is given, and from depth of cut you can calculate shear plane. So from using this depth of cut value you can calculate the shear plane length, and that length, how you can just calculate, I have shown here. This is the length here because this is the width, and this TS you can calculate by this T divided by sine phi, where T is depth of cut. And then we discussed about the formula that you need to remember, and that is the formula tan beta minus alpha, and we did this question yesterday also. And here we calculated mu, coefficient of friction, using this formula. Then we simply found out cutting power, but the main idea to make you do this question is to find out the length of shear plane, because we have not yet done a question in which that was asked, but we have done this now right here, and I think that is not that much hard for you to just grasp. So that's it for this question. Now let's move forward and continue our discussion with this question. So in this question it is given that angle of bite, what angle of bite is. So it is asking us, this question is asking us not what angle of bite is, but we have to know what angle of bite is. And it is asking that for hot rolling, is the angle of bite more than for cold rolling, or is it the other way around, or is angle of bite remains constant either for hot or cold rolling, or it is not important for hot rolling and cold rolling, the angle of bite. So we have to answer this question. First of all, you have to know what angle of bite represents, what it is. So let me just simply, this is one of the easy things that you can answer, easy questions, but here just you have to keep in mind this. You have to know what cold rolling is, you have to know what hot rolling is, and what angle of bite is. If you know each of these things separately, then you can just do this question. So first of all, what angle of bite is? Angle of bite is the angle which the contact length is making, contact length between the workpiece and the contact length between the workpiece and the rollers. So that contact region, that contact length, what angle it is making at the center is the angle of bite. So let's see this by looking at one of the rolling figures. So this is rolling, and here in rolling, this region is the contact length that I am just shading here so that you can properly see it, and this region will make some angle at the center, and this angle that this region is making at the center is, let's denote this as alpha, and this angle is the, simply this is the angle of PITE. So angle of bite you can understand from this very clearly, and you can now answer the question also. So we have to just discuss about angle of bite for cold versus hot rolling. So angle of bite for cold versus hot rolling we have to discuss, and for cold rolling we will get less draft. And what is draft? Draft is the reduction. So our initial height, if it is hi, our final height if it is hf, then for cold rolling we will be getting hi, which is the difference between hi and hf, that is the reduction, will be less for cold rolling because of strain hardening, and that strain hardening will decrease the ductility, therefore it will be and malleability will also be decreased. So simply what we can say, due to that, the capability or ability, not capability, the ability of this workpiece to be reduced due to the forces applied by the rollers due to the metal forming operation, that is rolling, will be decreased. So in hot rolling this is not the case, because in hot rolling strain hardening will not be there, because we have the hot rolling done at a temperature which is more than recrystallization temperature, and that recrystallization temperature, when we reach, we pass through recovery phenomena, and in recovery phenomena the stresses will be just gone from the grains. We will get stress-free grains. So stress-free equiax grains, new grains will be formed during the recrystallization process. So we will see that the ductility is higher for hot rolling operation of the workpiece, and therefore workpiece will let more reduction to happen. Therefore more reduction first of all will happen in hot rolling as compared to cold rolling, and since more reduction will offer, this angle of bite will be more for hot rolling as compared to cold rolling, and angle of bite will be less for cold rolling because of the less reduction. So if less amount of this reduction is happening, so you can see the angle formed at the center will be less, and for cold rolling if it is happening more, then the angle will simply become more. So from there you can just get this idea that which angle will be greater for which process. So bite angle will be greater for hot rolling due to the reasons that I have discussed, and I've also discussed why this is happening, why more amount of reduction is happening. It is happening due to recrystallization, and recrystallization phenomena occurs due to the fact that recrystallization phenomena occurs due to the reason that the process is going through a temperature which is the recrystallization temperature, and when we reach that temperature we pass through recovery, and that recovery lets the stresses to be reduced or stresses to be just removed, and we find the grains to be now stress-free grains. So that's why hot rolling lets more reduction to take place. So that's it for the discussion of this question, and now we can find the answer right here. Hot rolling is angle of bite for cold rolling will be lower, so B is the option that we have to choose. So this is the correct answer. Let me just take it properly. So now we will move onwards to our next question. So our next question is right here, and this question is again from the conventional part of the things, and this question is from shaping topic. So let's go through this question and do this right now. So a hydraulic shaping machine is set for 60 double strokes per minute while machining 8 job of 90 meter length. Ratio of cutting and idle speeds are given, and we have to assume a 5 mm approach and 5 mm overrun if the lateral feed per stroke is 0.6 millimeters and width of the job is 36 mm, then we have to find the machining time. So we will do solution from here onwards, and let's add a blank page also just in case, but we will do this, add that after seeing if we need the space or not. So first of all, what is given? It is given that shaping machine is having 60 double strokes per minute. So just remember here, the double strokes simply don't means that there is something written here two times. It is simply meaning simply double stroke is equal to strokes, because a stroke has a forward stroke and a backward stroke. So therefore that forward stroke and backward stroke together are written as double stroke. So double stroke is simply written for that, so it is simply strokes per minute. So n, that is stroke per minute, it is given to us as 60. And also we have to simply first of all find out machining time. So for machining time, we will first of all calculate the effective width, because in shaping, remember, in shaping and planing, we are taking the numerator as width to calculate machining time, not length, because we have to calculate the machining time by dividing the length which the feed direction is along. So feed direction is along width here, therefore we are taking width. But in turning and in milling, we see that the length is the feed direction is along the length only, so therefore we are taking their LE, effective length. But here effective width will be taken, and we will divide it by Fn, which is feed into number of strokes, to get our final answer. And the width of the job is given as 36, feed per stroke is given as 0.6. Assume 5 mm approach and 5 mm overrun. So we have to assume that, but let's see if we require that or not. So let's divide 36 divided by Fn. So Fn is 0.6 into 60. So the answer here will be coming out simply as so it is coming out as 1 minute, because strokes per minute was the unit of n, that is why we are getting the time in minutes. So again, easy questions, a lot of data was provided, but this question you can just think that this question is what you can be asked in your GATE examination, because in the recent GATE papers 18, 19 and 20, what we are seeing is that the examiners are asking us questions which are quite lengthy, and the length of the question doesn't mean that that question is difficult, because the lengthy question is simply giving you extra data and assumptions that you sometimes may need, and sometimes you might not need that. Therefore in this question you just saw that we didn't have any usage of ratio of cutting and idle speeds, that is quick return ratio. We didn't have the use of that also, and also we didn't have use of this approach and overrun, because that will go to make the length, effective length calculation. And we also didn't have the use of this 8 job of 90 mm length, this data. So overall we used only what we require, and we followed our basic, and we find out the answer is 1 minute, which is the machining timing for this particular question. So let's move forward and do our next question. But here remember that double stroke simply means as n, there is nothing new that you have to just consider there. So if strokes per minute is given, then that is fine, but if double strokes is given, then remember it is just simply stating for forward and backward stroke, and in one complete stroke we are taking account of both that, forward and return strokes. So we don't have to find effective width here, because the extra length that we have to, extra distance that we have to travel in the width is not given. It is only given for the length which is perpendicular to the feed that a tool covers, and that is not important for our machining time calculation. In machining time for shaping, our numerator has this width, so therefore the answer is 1 minute. And let's move onwards to our next question, which is again a very simple one. This is not from the conventional paper, but this question that we did just now was from the conventional GATE paper. So this question was as you can see, came a lot of years ago, but as 4 or 5 marks question. But this can certainly be asked as a 2 marks question or as a 1 marks question also, because of the amount of calculations involved here is not that much. It is just simply using one particular formula to make you get the answer. So the next question here is asking us that for deep drawing process, if the relation between height and diameter of drawn object, so what will be the relation between height of the drawn object, that is height of the cup, and diameter of the cup, for us to tell or us to just consider that process as deep drawing? And these are the options given. So is h should be greater than d by 2, or h should be less than half diameter, or h equal to half diameter, or h equal to d? So in deep drawing, what happens is that in deep drawing, we have a blank firstly with us, and this blank is having a thickness t, which remains throughout the process same, and the diameter of blank is d, and we are just making the shape of this blank changed after applying the forces, and the process is deep drawing, and the cup made is like this. So the drawing tablet of mine got tilted, that's why the figure got little bit tilted there. Let's do that properly. So the thickness will be same throughout this shape of cup. So this is blank, this is cup, and here small d is there, which is the diameter, and t thickness is still there, and we have this depth or height h, and it is asking that for this particular cup sizes, cup dimensions, what will be the relation between h and d? So h will be greater than, oh, I should write here small d, for the process to be called as deep drawing. So this is just a standard thing that we follow, because this is the standard thing we can just, so that we can just specify which, or just classify which process is which. So if this is done, then the process will be deep drawing. So the correct answer here will be A. The height of the cup or height of the drawn object should be greater than the diameter of the drawn object divided by 2. So simply this thing you have to remember, and it might get asked in your GATE examination. I have taken this question from the NPTEL website, which again are the questions produced from the IT, you can say, professors. So I have accumulated all this question from the standard places, so you can just do the questions which are quite good and quite standard in their quality, and therefore this question's answer is A. And you have to remember this particular thing, because if you don't remember this thing, that you can easily simply mistake this and leave this question, because if you remember this, you can solve this. If you don't remember this, you cannot solve this question. It is as simple as that. There is nothing you can do by logic, because this is one thing that defines a deep drawing process. So you have to remember this definition or this condition for the process to be called as deep drawing. So let's do the next question. So I hope there is no buffering today. So I adjusted the KB per second, that is bitrate of the stream. It was earlier 6000. So yesterday a student was there in the class who was facing the buffering quite a lot. So let's do our next question. So the next question here is from orthogonal cutting. So orthogonal cutting, in it the angle between cutting edge and cutting direction is. So to do this question, I have just taught you a lot about orthogonal machining, orthogonal cutting or turning, and we have to just remember one condition. I just told you to just remember three of the conditions for orthogonal cutting or machining, and by knowing that we can answer this question. So what will be the angle between cutting edge, that is the edge that is in contact with the workpiece that is making the cut, and the cutting direction, that is the direction where the tool is moving forward to make the cut, that is we can say feed direction. So the angle between both of them, what will be it? So let's draw one thing. So this is your workpiece, and this is your tool, single point cutting tool. So this angle right here is the side cutting edge angle, and this is the approach angle or principal cutting edge angle. And your tool is doing turning here, and the feed will be in this direction. And for orthogonal turning, we know that for orthogonal cutting or turning, we know that lambda is equal to 90 degrees. So this is one thing we can just understand or remember. For orthogonal turning, lambda, that is the approach angle or principal cutting angle, is 90 degree. So if we draw lambda here as 90 degrees, then what we will get? We will get the figure like this. So this is for orthogonal cutting where lambda is 90 degree. So your tool will now become something like this, and here the side cutting edge angle is coming out as 0 because lambda is 90 degree, and we know that CS plus lambda, that is approach angle, is giving us 90 degrees, and if one is 90 then other will be 0 to satisfy this equation. So here we can say the feed, which is the direction of cutting, and the cutting edge, which is this one, which is in contact with the workpiece, is having 90 degrees angle between them for orthogonal cutting. So I have shown you why 90 degree is the answer that we are getting, and I have also shown you orthogonal cutting diagram that you can make by just seeing the condition, and the condition is in orthogonal cutting or orthogonal turning or orthogonal machining, you are getting your approach angle equal to 90 degree to get the answer, because that is the assumption that you have to make along with this assumptions. So the three assumptions that you have to remember, that I think these three assumptions are the things that you can remember only, and rest you can get from using that. So you can just remember that first of all, approach angle is 90 degrees there, and the tangential cutting force is equal to cutting force, and the axial cutting force is equal to the thrust force. So therefore we can take that values and make them equal to FC and FT, and then use that FC and FT to calculate other things like the frictional angle, like shear force, and just draw the merchant circle using that. So therefore these are the three conditions, three assumptions that we have to make for orthogonal cutting, and the answer to this question will be 90 degree. So we have done 1, 2, 3, 4, 5, 6. 6 question has been done by us in a matter of just an hour or so. So let's continue and do the next questions, which are this one, which is about discontinuous chip formation. Then we have heat, which part is having most amount of heat transferred to it, so we will discuss about that also. And after that we will discuss about this particular question, that is from the sheet metal operation, and here a shear is being made in the blade or in the punching tool. So we will do this three questions, and then we will see if we have time to do more question or not. So right now what I am doing is I am just going to see if the stream here is going on properly or not. So let's take a little break. So let's continue our discussion. So we just discussed this very neatly and very properly, that why in orthogonal cutting the angle between cutting edge and cutting direction is 90 degrees, and I have shown you that in orthogonal cutting and that in general the standard cutting operation that we study, where lambda is not necessarily 90 degree, that is approach angle is not 90 degrees always, but for cutting that is orthogonal we assume that. So now what we are going to do here is we are going to discuss about our next question. So our next question is simply stating us that, asking us that in machining process a set of conditions favoring the discontinuous chip formation is brittle work material, low cutting speed and high feed. Ductile work material, low cutting speed, high feed. Ductile work material, low cutting speed, low feed. Brittle work material, high cutting speed, low feed. So first of all, what discontinuous chips are? So discontinuous chips are first of all the chips which are not, as the name suggests, continuous. They are of short lengths, they break, they don't just become, don't just keep on forming, they just break after a certain length, and this type of chips are preferred. If this type of chips are forming, then we can say that machinability is good. And for discontinuous chips to be formed, first of all the work material needs to be brittle. So the option B and C is not correct. We can just deduce it from the fact that discontinuous chips are only forming when the work material is brittle, such as grey cast iron. That type of work material which is brittle, then the discontinuous chip is forming, and the feed should be large for discontinuous chips to be formed. So large feed is another condition for that, and cutting speed should be low. So the answer should be A, brittle work material, low cutting speed, high feed. And you have to remember these things. There is nothing that you have to just go in deep and just understand, and the things that you have to do that for the things I am already teaching you, I am already making that you are understanding the things which you need to understand properly. But right here we don't need to go on deep, we just need to remember these things, these conditions, that work material brittle, feed large, and cutting speed low for discontinuous chips to be formed. And at the end of the class we will discuss about the types of chips, but for now we will leave it like this. We will do the questions, and at the end we will have a nice theory section of our class where we will discuss clearly what type of chips are there: continuous chips, discontinuous chips, continuous chips with built edge formation, and also we will discuss about the serrated chips, which are quite different, and due to the strength there, they are having a quite different shape. So we will discuss all this at the end of this class, but since that requires a nice large theory section, so we will do that at the end only. So let's see the other question here. So during metal cutting, that is during a machining process where material is getting removed, what is happening? So is most of the heat is transferred to the chip, is most of the heat is transferred to the workpiece, or is most of the heat is getting transferred to the tool? or is heat is generated equally and it is distributed, or heat generated equally distributed amongst tool, workpiece and chip. So equally distributed is not the correct answer. The correct answer we will see after drawing this graph. I think you will get to know this properly. So let me just go back and add a blank slide. So I'm going to draw it, then I will discuss it. So let me draw the graph to properly let you know how heat is getting transferred during a metal cutting operation. Let us write it like this only, because well, let me just tilt my so it is better that we write it simply. So let us write here high cutting speed, for we have to answer the question that we were just discussing before drawing this. And now the regions here are showing. First, this region is so we have to, since we have to discuss for high cutting speed, so we will keep our focus there only. So there, let us let me just give you two set of values here and here. So this values I am providing you just to give you an idea at how the heat transferred is distributed among tool, chip and workpiece. And the values that I'm writing is the values in, will give the values in percentages. So as you can see, I have written here this y-axis is showing us the heat generated in machining. It is showing that. So the y-axis is showing the heat generated during machining in percentages, and x-axis is showing simply the cutting speed. So we have our total heat generated 100% shown at the top, and for the origin it will be 0% heat generated in machining. So for high cutting speed, I have given you two set of values. The first set is having 15% heat generated going to workpiece, 15% going to tool, and the rest 70% going to chip. And then we have 10% going to workpiece, 10% going to tool, then 80% that is left going to chip. So you can see from this figure and understand that at high speeds, a large amount of or large percentage of heat, which is far larger than the percentages of heat even combined given to workpiece or distributed to workpiece and tool, is given to chip. So 70 and 80% from the data that I have given you, just to give you an idea, is given to chip. So at high speed, the highest amount of heat is getting transferred to chip. So that will be the answer here. So most of the heat is transferred to chip at high speeds for metal cutting. So that is the thing, and how you can remember that. So if for example it is asked that what will be the percentages of heat typically carried by chips at high speed, then you can also write from the data it is generally 80%, 70%, like that. And other options will be given if that type of question is asked. Other options will be given very low, and one option will be given which is of the order 70s or 80s. So you can give the answer like that, because you know that at high speed the percentage of heat going to chip is far greater than the percentage of heat that is getting transferred to workpiece or tool. So chip is just taking away all the heat, and that is the thing that we require also, because if more heat is going to workpiece and tool, for say, let's say if tool is taking more heat and chip is not taking, let's say chip is taking zero heat and tool is taking for example 60-70% of heat, or even 50% of heat, then what will happen, its geometry will become changed. And we have studied that tool geometry is very important, because tool geometry has a parameters like rake angle, side cutting edge angle, and nose radius. So if the parameters are starting to get changed due to expansion, due to the more heating of that tool, then we will find our final desired shapes are not getting obtained, and also the tool will be getting softer because of the more heat that is being now transferred to it. And if it is getting softer, and if it by chance if gets more soft than the workpiece, then there will be reverse cutting and the tool will be getting weird, and therefore it is better that more amount of heat is getting disposed with the chip and less amount of heat is transferred to workpiece and tool. So therefore this question's answer will be A, most of the heat is transferred to chip. Now let's do the conventional question here, conventional numerical question, which is from the topic sheet metal cutting. So let's do that. So in this question it is quite on the easier side, because we have already done this question in one of our classes, not in the important section, important question class, but we have done that in I think in the class where we discussed about metal forming questions particularly. And also I have taken particularly one class or where I have just talked about all the sheet metal questions along with theoretical questions and numerical questions. So you can just take a look if you want to. So what the question is asking us, let's see. So it is asking, estimate the reduction in piercing load for producing a circular hole of 50 diameter in a 3 thick steel strip when the punch was provided with a shear of 1 Assume 30% penetration and strength of steel as 400 megapascals. So first of all, we have to find reduction in piercing load. And why there is reduction in piercing load? Because we are providing the punch with a shear of 1 So if punch is provided with a shear, then there will be reduced load, because now the area over which the load is just given will be greater due to that shear. So you will find your force versus displacement curve to be changed in shape after you have provided the shear, and your maximum force will be now distributed over a displacement or over a large distance than the case where you were not provided shear. So shear basically is reducing the maximum force, not the total energy is getting reduced. It is going to be same, just the maximum force is getting reduced. So we will first of all find the maximum force which we are going to get without shear, which is quite simple to get because it is just one I think one equation. And we will then find the value of the force which we have obtained after we have provided the punch with a shear of 1 and it is given 30% penetration is there. And always when the penetration is given, you should remember the penetration is 30% of what? 30% of thickness. And shear strength is given as 400 megapascal, so that is also required to calculate first of all the maximum force. So let's first calculate maximum force. So you can do this question I think in under 1 minute. So that is the time that you should take to do this question. And if you are doing this question in your uh, just a recorded session of watching this recorded session of the class or an archive session, then I'm giving you 60 seconds to do that. So just set the timer or look into the clock and do this question under 1 minute. So maximum force is calculated by this equation pi d, which will give the length which is in contact with the punch, and thickness t, and shear strength tau. Let's write it as tau s. So pi into diameter is 50 t is 3 and tau is 400 megapascal. So megapascal is in Newton per square. So we will get this value in Newton because square of 50, that is diameter and thickness, will get cancelled with the megapascal square which is at the denominator. So our answer to this So where we left before this very annoying issue of electricity just made this class disconnected. So we were discussing about the shear that is provided on the punch that is reducing the piercing load, and we have to find the reduction in piercing load. So let's just first of all calculate the maximum load, because as I have discussed before getting disconnected, that due to providing of shear, the maximum force will be now less, because it will be now distributed over the length that is there due to the shear. So our value of this was coming out as, so let me write this in kilonewtons because it was coming out quite big. So 188.49 kilonewton is the maximum force, and we will see that the shear is making this value, or is coming as less than this value. So force required with shear on punch is given as this formula, because in the question it is given as circular hole. So for circular hole we are using this formula to calculate force when shear is provided. So it is maximum force cross penetration into thickness divided by the amount of shear which is provided on the punch plus penetration into thickness. So what we will have here is 188.49 into pt. So p is 0.3, t is 3 mm. So let me just write it here. So we should just convert this mm into meter now, or we cannot just do that also, because at the bottom we have to also do one calculation of length unit, and that mm will get cancelled, and our answer will come out simply as in Newton units. So 1 plus 0.3 into 3. So what we will have here is 0.3 into 3 divided by 1 plus 0.3 into 3. So it is coming out as 89.28 newtons. So what will be the reduction? So delta F, that is the change or the reduction, will be maximum force minus the force that we are getting due to this shear which is provided. So our answer here will become 99.20 newtons. So not Newton, we should say it as a kilonewton, because this is the unit and which we are using to calculate. So it is in kilonewtons. So again you can see why this is happening, because we are providing a shear on the punch, and therefore the why this is happening again and again, I think some button is getting pressed. So if you are providing shear on the punch, then your tool will have its maximum force reduced, because of the length or the distance over which it has to cut is now more. So therefore you will have this thing. Let me just draw one more thing also here. So for that we will need a new page. So what we are discussing is shear on, let us write it like this: if shear is provided on punch, then what will happen is that if shear was not provided in punch, first of all let us just draw if shear is provided on punch. So like here you can see a shear is provided, and this is the shear angle, and this is the shear which is provided S. So distance traveled by the punch here is more due to us providing this shear. And let me also show it clearly that this is your workpiece and this is the cutting that is happening due to force or stress exceeding the shear strength, and this right here is your tool with shear or punch with shear. So not tool, let us just write it as punch. So if shear is provided, so the tool will be moving in this direction. The force versus displacement curve will look now like this. So this here is displacement, this here is force. So it will look now like this, that is a trapezoidal shape is obtained, and you can see over a large number of area the force is now distributed or just obtained. And we will draw this figure also for a punch where shear is not provided. So let me do that also. So this is your punch, and here you can see there is no shear angle is 0. Or you can also look into like this way, that the shear is 0, S is 0. It is also going in downward direction because that's where we have to go to remove the material and to make the cut. Let us draw here the force versus displacement graph for a punch with no shear. So F displacement. Simply, first of all, we need to just know that here maximum force will be more, and it will just when the punch here will come in contact with your workpiece, the maximum force will be reached suddenly, and then we will have it reduced as the punch move forwards. So overall this will be what your force versus displacement graph will look like. So triangular, maximum force. Displacement here is quite you can say less or very less than the displacement at the figure shown with the punch with shear. It can vary and depend upon the amount of shear provided, but the area that this trapezoid has, so area of both the graphs are same because energy there will be same, but the maximum force encountered will be less. So that's why we are producing or providing shear. So the main aim here is to reduce the force due to distance travel being more. Maximum force, not the total energy. So let me just clearly write here also that energy same since area is same for both. And what we have discussed here is also that we have to estimate the reduction in piercing load due to providing of that shear, and that shear is provided due to to do that reduction in maximum force, and we have obtained the maximum force. It is reduced by a value of 99.20 kilonewtons, which is just equal to what the shear force is. So it is reduced by half value. So that is a lot of good thing to have that force reduced. And again in this question we can see that the penetration that we have discussed, we have to take it as percentage of t, small t, which is the thickness, and thickness here is given as 30%. So penetration will be simply given as 30%. We have to take by ourselves that it is 30% of 3, that is sheet strip thickness. So that's it for this question, and I think that will be it for this class. I have told to discuss about this continuous chip, discontinuous chip, and the other chip types, but we will do that in our next class that will be happening tomorrow. I will just take the time out and make that discussion during the class that is upcoming. So because it is quite lengthy sections and we have to just discuss it in detail, and we will discuss it by seeing nice figures that I will be just collecting and drawing. So we will see that in the next class. So let's see what we have discussed today. So we have discussed quite a large number of questions today. So first of all, we discussed about this question in which it was asking us that in sheet metal processing the main function of punching process is. So we discussed that punching's main process is to create hole, and blanking's main function is to create blank. And we look at this figure. Let me show you that. So that figure is not available here at the moment, but let us just add that. So if you have missed one of the questions, or if you have joined late, then I am just summarizing what we have discussed in today's class. So this is the figure that I am talking about. This figure is clearly showing what blanking is, what piercing is, what is scrap for blanking, what is scrap for piercing, what is workpiece or our desired part for blanking and for piercing. And I also just told you how you can just easily relate piercing, because ear piercing is done where the main part is the thing that is left after creating hole. Nose piercing is also done that. So to just wear jewelries and earrings like that. So controlling hole size, or is it controlling the blank size? Or similar for die, it was asking the same thing. So we discussed that punch size will be the same of hole size. You can remember this by the name. Punching creates the hole as scrap, so that thing should be removed. So punch size will be same as hole size, and in punching therefore clearance will be provided on die. And in die size will be equal to the blank size. So in blanking, clearance will be provided on punch. So that is the thing that you can remember here. So that is another question, nice question that can be asked in the GATE examination. Clearly it is a very conceptual question. Here it is not only checking that you know what punching and blanking is, but you also have to know to answer this question where you provide clearance. So this is covering a lot of things for that sheet metal operation topic. And then we discussed about this question where we were provided with two lathes, engine lathe and turret lathe, and we have to find out what are the minimum number of parts required to make the turret lathe more economical, because the turret lathe was asking for additional 500, and also the hourly rate of turret lathe was greater. So we have to find out that, and we found out that by just making the cost of both equal for a certain number of units, and we found out that unit coming out to be 20.83, I think, and that 20.83 we have to convert it into whole number, because 20.83 is nothing, that is nothing we can say for number of parts. Minimum of number of parts should be 21, it should be a whole number. So take care of that you are not answering everything as it is, you are answering some things by just converting into it into logical number. Then we did this question where some of the things were just that we discussed before, but since this was a conventional question that came in GATE, so it is always better that we do this type of questions. If the question is different, then we should just do it so that we can revise the concepts. But here the third part was new that we have not discussed before. The length of the shear plane was asked, and we discussed that in detail by drawing the figure that you can see in the screen below. So length of the shear plane was coming out as the depth of cut T there divided by the value sine phi, because in the right angle triangle here the sine phi is equal to T by Ts, that is perpendicular by thickness. So that is again a nice thing that you can just remember. This is the figure, this triangle I have drawn here. This is the shear plane. This AB is the shear plane. The ABCD is the shear plane. AB is the shear line, you can say, C, and phi is the shear angle which was provided to us in the question. And I also told you to remember this tan beta minus alpha like our previous class. I just recommend you to remember the formula to calculate beta, which is the frictional angle that we can use to calculate mu, that is the coefficient of friction. It is equal to tan beta. Then we discussed about angle of bite and why angle of bite is lower for cold rolling than what we encounter angle of bite in hot rolling. So this is what we discussed. We discussed that due to recrystallization, what was happening is that due to recrystallization, the recovery was taking place before we encountered or before we just reached the recrystallization phenomena, and that recovery was making the strain hardened stressed grains stress-free, equiaxed, and new grains were also forming during the recrystallization, which is what happens during hot rolling. Therefore ductility was getting improved, and therefore more reduction can happen in a hot rolling than in a cold rolling process, and therefore the angle of bite will be greater, because angle of bite is the angle that the contact length is making with the center. So that is one thing that you can also just see here, look here, understand here. Another nice question which is not asked yet in the GATE examination, which might get asked sometime in the near future, because it is again GATE is only asking us to calculate angle of bite and something like that, which is again very repeated question. So this is another new type of question which is still nothing new, but it is framed in such a way that you have to apply a little bit of thinking here before answering the question. And you have to also know about hot rolling and cold rolling, about recrystallization and all this to answer. And then we did this question where the question was very lengthy, which follows the same approach, or we can say which is similar to what we have encountered in 18, 19 and 20 GATE examination, but the approach to do us to do answer this was very simple. We have to just follow the basic concept here. The machining time for a shaping and planing operation is simply width divided by Fn, which is the axial speed. Here Fnn was given to us, and n was given as double strokes per minute, which is simply representing forward and return strokes. So a complete stroke is including that. So simply double strokes simply means strokes, one stroke. So 60 strokes per minute was n given, and we were provided with a lot of extra data which were not useful, and this again was a GATE conventional question which was asked a long time ago. But again, nice question, because we have to keep it very simple. This might get asked as 1 marks question, and a lot of things was given to confuse you, but simply we have to put the width 36 and divide it by the product of f and n, and our answer then came out to be 1 minute in minute, because of the stroke being in stroke value being in 60 strokes per minute, the n value. Then we did this question where we have to just find out or just remember the condition that this h, the height of cup, and the diameter of cup, or diameter and height of the drawn object, are related for the process to be called deep drawing. You have to know this relation. There is no escaping this, because if you don't know, then you cannot answer this question, or you might answer this question by just some luck, but you have to know the conditions. Conditions is something that you cannot just think about. You have to just remember them, because these are the standards that have been just made to define a process. And for this particular deep drawing process, height of the cup should be greater than half diameter of the cup for the process to be called as deep drawing. Then we discussed about this orthogonal and cutting operation, where what will be the cutting edge angle and cutting direction, what will be the cutting edge and cutting direction, what will be the angle formed between this cutting edge and cutting direction. So we discussed that side cutting edge angle and approach angle, or principal cutting edge angle, and we discussed how a single point cutting turning operation looks like, where feed is provided. And we also discussed about this CS plus lambda is always equals to 90 degrees. So side cutting edge angle plus lambda, that is the approach angle, is 90 degree. For orthogonal cutting, we discussed the assumptions that we should know, and that assumptions are listed just above the orthogonal cutting word there. They are approach angle 90 degree, tangential cutting force equal to the cutting force, and the axial cutting force is equal to the thrust force. And we found out that for the orthogonal cutting, the figure looks like the second one, and therefore the angle between the cutting direction, that is the direction in which the feed is going on, and the cutting edge will be 90 degrees. So in the cutting direction, the velocity is also being provided, so you have to remember that also. So now we discussed our next question as this. So this question was simply asking that what was the condition, what is the condition for discontinuous chip formation. And we discussed that the condition that you have to remember for discontinuous chip is brittle work material, large feed, and low cutting speed. And remember, ductile material gives continuous chip, not discontinuous chip. And discontinuous chip, we discussed about them that they are better, because it means that they are preferred, because it means that better machining is done. And these are the conditions that you have to remember. So there is nothing that you can just think about and just answer. These things you have to remember and then answer. So I will discuss about types of chips in my next class. It is a theoretical section, and there are quite of things that we have to discuss, quite a lot of conditions that we have to discuss. We will also see figures in the next class. And then in the next question we discussed today was this, during metal cutting at high speed, where in which part among chip, workpiece, and tool most of the heat was getting transferred. And we discussed that by drawing this figure quickly, and we saw the at high speed here. So this x-axis is representing the high speed, not high speed, the cutting speed, and the y-axis is representing the heat generated in machining in percentages. So at high speed, you can see in this region, I have given you two set of values just to make you understand it properly, that the highest amount of heat is getting transferred to chip, which is basically in the range of 70 to 80%, and the rest heat is equally there in the transfer to the workpiece and tool. So that is what we desire also, because we don't want more heat to be transferred to tool or workpiece, because if more heat is transferred to tool, it can become soft, and it can also change its dimensions due to expansion and all that. So our preferred condition is more heat should be going to the chip and getting disposed, and the heat is generated mainly due to friction and the cutting operation that is being performed. So we discussed that, and the answer to this question was most of the heat is transferred to the chip for metal cutting at or during metal cutting at high speed. Then our last question of the day, we discussed about this reduction in piercing load for producing a circular hole. So for producing a circular hole, we found out that this is the formula that we follow, that shear force is given by, or force when the shear is given provided in the punch is given by F max into PT divided by S plus PT, where S is shear. In the question it is given that shear is 1 mm, and we first of all provided find out the maximum force, which came out to be 188.49 kilonewtons, but we did that after using this formula pi dt by tau s, where pi d is the perimeter, because that is what is getting in contact with the punch, the length, and t is the thickness, tau is the shear strength, which is 400 megapascal, and we found the answer in Newton above when we converted into kilonewton, because of the value coming out to be quite large. And then we found out F, that is shear force when shear is provided on the punch, and we found out that it is quite less, and how much it is getting reduced due to the shear providing in the punch, or the shear that we have given in the punch. We found out the value was, the force value was getting reduced by 99.02 or 0.20 kilonewtons. So that is quite a large value, and this is how the thing we have discussed. If shear is provided on the punch, then how the force versus displacement curve is looking like. You can see the punch, if not given shear, then the maximum force there in the graph is more, and the punch if given with the with this shear, then the maximum force there is not that much high, but distance traveled by the punch is more, so the force now is distributed over the area, and the energy is same. Since the area is same, I have also written that and discussed that there. And shear angle and shear, how we have we can see in the figure also on the punch how it is providing and how the cutting is taking place. Again, you can see the distance traveled will be more due to providing of shear. So that's it. That's the things that we have discussed for this class. So that will be it. And again, if you found this class helpful, if you found this class engaging, if you found the concepts here beneficial, and if you just got better prepared after watching the class, then hit the like button and subscribe to this channel. Hit the bell icon for notification, so that you can get notified whenever I and some other educator goes live, so you can attend his or her class according to your changing of your schedule, or according to your schedule simply. So 10% off code is ABHIMI. This is the code that you have to use, that you can use to get 10% extra discount. And I also teach in Unacademy's website, so there you can come and attend the classes. You can if you have missed the classes, you can also attend the classes there, and this code will give you extra discount, which is the discount which is already provided. There is one discount which is already provided by the Unacademy's team, but we are you can use this code to get extra discount. And again, this code is universal code, so you can use this for any exam other than GATE also, and you can also share this with other students and your friends also, so that they can also take advantage of this code and study from Unacademy. And remember, just be calm. GATE is just an examination. Do your best, prepare your best, but be calm. Don't be stressed about GATE examination all the time. You have to just be focused and be calm and study, and rest will be happening good. So again, be calm, study with your best focus, with a whole lot of focus, and just subscribe to one of the Unacademy subscription that you need and that you can afford, and start your preparation, start giving test series, start seeing the analysis, start mainly seeing the analysis, because you need to make your performance better. After giving test series, you have to learn from mistake. So that's it for today's class. Thank you for watching. Stay safe and take care, and best of luck for your preparation. So that's it for today's class.